We're back again, nation, and this time we are doing a series on creational design patterns. This series will be in Java. It will be creational design patterns in Java, and we'll be talking about why do we have these patterns and when to use them and the benefits of having them. And we'll also be coding. I'll code some examples and talk you guys through it. So the patterns that we'll be discussing in this series are the factory method design pattern and the abstract factory method design pattern, the singleton method design pattern, the prototype method design pattern, and then the builder method design pattern. So those are the patterns that we'll be discussing in this series. Please stay tuned. Let's go. Back again, Leviathan Nation. Starting off the series with what is a factory design pattern method. So, the factory design pattern method is a foundational creational pattern used to outsource object instantiation, promoting loose coupling and the open close principle. So the open close principle is one of the principles in solid used in object-oriented programming in Java, and its definition is that software entities like classes, method, modules should be open for extension but closed for modification. We try to limit or we prohibit modification at all costs. So we build our software in a manner where we can easily extend the functionality of it as we scale, rather than making updates or alterations to the code. I'll touch a bit later on that on the next slide. Okay, let's go to the next slide. So the factory design pattern method example. So in the factory design pattern method, the factory design pattern, we usually have our product interface, our concrete class, and then our concrete class or concrete classes, and then our factory class, which is a factory class is responsible for actually creating all these objects. So start with a nice overview. Here we have the product interface. There it is. It's an animal product interface. That means since on this factory design pattern example we'll be creating animals, that's why our product interface goes by animal. And below that we have our concrete classes. As you see here below, we have the dog class implementing the animal interface, and below that we have the cat class implementing the animal interface. And as you see here above the interface, we expect all animals to make a sound. So after implementing the interface, we are forced to have a functionality of a sound for the dog. And as you see here, we are printing out the dog box woof woof whenever the sound method would be invoked for the dog object, and for the cat object we say the cat meow. These are the concrete classes. These concrete classes extend our product interface, which is our main interface. And let's go to the next slide. The next slide is the factory class. The factory animal class. So the factory animal class is the class that is responsible for creating the animal objects depending on the type that is passed in. As you can see there above, we have the type enum, it has the cat and the dog, the two clauses, the two concrete clauses that we had on the slide previously. So this factory clause have a static method, which is create animal. So we take in the animal type. If the type is of type dog, we return the dog object, and if the type is from cat, we return the cat object. If we didn't pass nothing in as an argument, we just say insert animal type, since we throw an exception of that says the user should insert the animal type, because that we need an animal value for us to be able to create the animal. So before, we must have seen that I've touched base on the open close principle and solid principle. So that means all we have to do, let me go back to the previous slide. If we were to want to add a for example a fox clause, we just create the public fox clause and extend the animal, and then make the sound that, and implement the method of the sound, which would be the sound that the fox would make. And the only thing that we need to do is just come here to this create animal method and add the case for the fox, and then we should return the fox object. You don't have to modify any places, any code, do any alteration. It's more of like we extend the functionality instead of doing any modifications to it, to existing code. It's quite nice. It scales quite nicely. And then here we have our main class. See the main class. We have our animal product class, dog, and I named it dog instead of animal because like my intent was to create a dog, and call the animal factory class dot create animal method. And as you see here, I've passed in the dog in them, and then if I invoke the dot sound, if I want the animal to make the sound, the expected results that should be printed out should be the dog barks woof woof, since that's what I have for the dog subclass that implements the animal class. So ladies and gentlemen, that's your factory design pattern method. So now the next thing that we'll do, we'll code the example and just talk about it as we recode this example on our IDE. So please stay tuned. Let's go. So now let's code our factory method design pattern. Okay, let me do this. Animal, let's start with our product interface and have our sound method signature that we would like all our concrete classes to implement. Let me start off with our concrete class dog, which is an animal. Implement animal interface, implement sound. Okay, done. Whenever we invoke the sound method, the dog sound method, we expect the dog barks woof woof to be printed out. Let's try the cat concrete class. Implement animal interface. Sound The cat meow meow. The cat meow meow. So yeah, these are our two concrete classes that implement our animal product class. And then let's create our enum type. Type enum. This enum will help us decide which object to create inside our factory class. And then let's go to our factory class. Create our factory class, our animal factory class. The class that will be responsible for creating our animals. Yeah, so let's make it public static animal and say create animal. So we expect to pass in the animal type. We expect the user to pass in the animal type, animal enum type, which will be our dog or our cat, and from the type that is passed in, we will create a animal object from that type. So let's return switch type. Some case new cat, and when it's a dog that's passed in, some new dog, and case when it's a null, let's pass in, we throw an exception, throw new illegal argument exception, please insert a animal type. Whenever a user passes in a null value, a null type, and this is just a safeguard. So let's verify. Okay, we have our animal product type, product interface, and then our concrete classes that actually implement the sound signature, which is the sound method, which is at our animal product. We have it for our cat. We have our cat concrete class, and we have our dog concrete class. And then let's go over to our main and test this out. Let me say animal and get the animal factory class. Create type. Yeah, let me take in the dog. Yeah, that sound. What I expect, the sound that I'm expecting to come from this animal is woof woof, since I've taken in the dog argument. Yeah, let's test that out. Wow, look at that. The dog barks woof woof as expected. And then let's try to create another animal. So animal factory class, static class, same type, cat, cat. The sound that we want to come from the second animal is the cat meows. Is the cat meowing? But let's put that with test. Oh, lovely. There we have it. The cat meow. And on top we have the dog barks woof woof. Yeah, okay. Yeah, thanks, yeah, for staying with me. Yeah, ladies and gentlemen, yeah, so yeah, this concludes our factory method design pattern example uh, through code. Yeah, so yeah, next we'll be looking into the abstract factory method design pattern. So please stay tuned. Let's go. Okay, so what is a abstract factory design pattern? The abstract factory design pattern is a creational pattern that produces families of related or dependent objects without specifying their concrete clauses. It's often called a factory of factories. It defines an interface for creating objects, letting subclasses determine which product to create. The benefit of this design pattern is that it ensures objects from the same family are used together, and it decouples code from concrete classes, and it makes systems easier to extend, and it follows the open and close principle, and it also promotes consistency among all products. Let's go to the next slide. So here we have our abstract factory design pattern example. We have our product interfaces, we have our core interface, our engine interface. Since this example is on core products, for our core interface that have the drive signature method, and below that we have our engine interface that has the start signature method. Let's go on to the next slide and see what will happen. So here we have a Toyota products. For our Toyota products, we have a Toyota core subclass that implement the core interface that we had previously, and we are required to implement the drive method. So meaning whenever we try to call this drive method from the Toyota class object, we should print out driving a Toyota car, and below that we have our Toyota engine class that implements the engine interface, and we also require to implement the start method. And when we try to invoke the start method from the Toyota engine subclass, we should have starting a Toyota engine printed out on our console. Let's go on to the next slide. Now with our BMW products, we have BMW car that implements the car interface, and when we try to invoke the drive method from the BMW car class object, we should have driving a BMW car printed out on our console, and below that we have a BMW engine class that implements the engine interface, and we are also required to implement the start method, which when invoked should print out starting a BMW engine. Can you guys see the consistency in the products? The engine, the Toyota product follow the same procedure, and look, the BM product is also following the same procedure. If you were to add a new product, maybe a Mercedes, will also have follow the same procedure, which is quite great for consistency. And then we have our abstract factory interface that helps us in building our products. Okay, let's go to the next slide. Here we have our Toyota factory class that implements the car factory interface. It will help us now build our Toyota product up. We are required to implement the create core interface. No, the create core, my bad. The create core method, and we just return the Toyota core object, and below that we're required to create the engine, and we just return the Toyota engine object. Let's go to the next slide. This is the Toyota factory, and then we have a BMW factory that implements the car factory interface, and we are required to implement the create car method as well, and we just return the new BMW car object. And below that we're required to implement the create engine method, and we just return the new BMW engine object. Let's go to the next slide, and here we have our client code. So we have our car factory factory interface, and we have our factory reference. We just say equals to new Toyota factory, so that means we will go with the Toyota. We will now start our process of creating our Toyota product. Below that we have our we invoke our create car method, and we will create our Toyota car. We will create our Toyota car object, and below that we have a create engine method invoked from the factory interface, and there we will just create our Toyota engine object. And below we have car.drive invoked and engine.start invoked. Whenever we call the car.drive method, we should have driving a Toyota car printed out, and below we have a engine.start method invoked from the engine interface, and we should have starting a Toyota engine printed out. The same would go for BMW. If you were to, at the factory reference, if you were to say equals to new BMW factory, you should have driving a BMW car printed out and starting a BMW engine printed out instead of the current expected results. But yeah, we'll also be coding next. That's what we'll be doing next, and just explore this abstract factory design pattern through our code, and yeah, go into it a bit in depth and try on some more cool stuff. Yes, so please stay tuned. Let's go. Okay, now we'll be coding the abstract factory design pattern example. We'll try to show it to code, and I'll try to go into more into depth about abstract factory design pattern through this coding practice. Okay, let's start off with router package, and also our BMW package. Lovely. And add our core interface, which should have our drive as a signature, and then let's have our engine interface, which should have our start as a signature. So now let's create our Toyota car. Okay, Toyota car, and implement the car interface. Let's do that. Just print out driving a Toyota car, and yeah, let's also create our engine. Toyota engine class and implement the engine interface with the start method, and we can just say starting a Toyota engine. Yeah, sure. Yeah, make this capital. See, yeah, okay, same as here. And now let's build our Toyota factory class. Toyota factory class. Okay. Yeah. Before we build our Toyota factory class, we should have a factory interface. Our car factory interface. Car, okay, yeah. Rename. We should have car interface, and we should say create car method signature, and then we should also have engine interface and say create engine signature. So in our Toyota factory, we'll have to implement the car interface, and yeah, just implement the methods for that. Since we already have our Toyota car, we'll just say new Toyota car, return the Toyota, and for engine, just say new Toyota engine, return Toyota engine class. Now let's come here and let's say car factory is equal to new Toyota factory, and try to create the car. Okay, let me implement, yeah. So let me say car is equal to factory and create our car object, and have our engine interface so equal to from this factory class create our engine. And now let's say car dot drive. You will call a drive and car dot, okay, yeah, car dot drive and engine dot start. Let's see what happens when we invoke those methods. Ah, lovely. We have driving a Toyota car printed out and starting a Toyota engine printed out. Yeah, so now let's quickly create our PM product. Okay, let's say BMW car, implement the car interface, implement methods, says out, okay, driving a BMW car, also create a new class which is BMW engine. Yeah, let's just implement the engine interface, and yeah, let's say out starting a BMW engine, print it out. And yeah, we can also, yeah, now let's create our BMW factory class and implement the core factory interface. Can just return the new BMW core whenever we have to create a car from the BMW factory object. New BMW engine, return BMW engine whenever we try to create the BMW engine. So now I'll just go to the main, just see how cool this is. Instead of saying new Toyota, I'll say new BMW factory, and let's see what happens when you try to drive, even start our engine from the BMW factory. Lovely. We have driving a BMW core printed out and starting a BMW engine printed out. Yeah, so yeah, ladies and gentlemen, that was your example on abstract factory method design pattern. So what is a singleton design pattern? A singleton design pattern is a creational design pattern that ensures a class has only one instance and provides a global access point to that instance, which is useful in situations like database connections or configuration managers where only one shared object is needed to save memory and maintain consistency. Yeah, this is our next slide, where we have our singleton design pattern example. As you see here, we have our singleton class, and we also have our instance, our static instance variable that is our current singleton object. So you will see the instance variable, we've made it static. That means it's not an object variable, it's a class variable. The moment this class is uploaded on the JVM, a new singleton object is automatically created with the class, and we can access that object through the static method right below where we have get instance. That is how we can access that variable that is created with the class. That means we can't alter the instance variable. It will always be the variable, it will always be the object that was created with the class. We can't update the object, change the object. And above the get instance method, you will see we have a private constructor which prints out the singleton instance created. You will understand more of how the instance is created on our next example. Let's go to our next example. Yeah, here we have our main class and our main method, static method. So as you see, we have our singleton object 1 is equal to singleton.get instance, that get instance which we're getting the singleton object, and we also have object 2 making the get instance call. Again, what you would assume, someone else might assume, okay, when we call the get instance, a new singleton object is created. But no, what's actually happening here is, since the private instance variable is a static variable, that means it's a class variable. It was generated with the class when the class was added at the JVM. Now we're just getting that variable, just getting that object, the singleton object, and below we have a check to check if the first object is equal to the second object. If they both are equal, we'll have both objects are the same instance printed out. So the expected result when we run the main method should be singleton instance created, and then both objects are the same instance printed out. We should have those two results printed out. Yeah, so next we'll be coding this example, putting it to a test, and I'll be talking you guys through it. And yeah, let's go. Yeah, so we're back again. So now we'll be coding the singleton design pattern example. Yeah, let's go to our singleton method package and create our new class, which will be our singleton class. And then start off with the private static singleton instance singleton create a private constructor singleton and salt new singleton instance created private static singleton get instance and return instance or instance. Yep. Let's make it final. Yeah, so yeah, this is our private static instance variable that will be created with our class when the class is added in our JVM. And this let's make this public. My bad, sorry. And then we have our public method that will get our instance. Yeah, that's okay. So yeah, let's go to our main class, and in our main class we can just say singleton is equal to singleton.get instance, say singleton is equal to singleton.get instance and say if go to Singleton, sign both reference and same reference the same object printed out. So when I run this main method, I'm expecting to have new singleton instance created printed out, and both reference the same object printed out. Let's put it to a test. Yeah, exactly as I'd expect. New singleton instance created, both reference the same object. That means we've successfully created our singleton class, and it's working as it should. Yeah, so yeah, that's it on the singleton method design pattern. Yeah, please stay tuned. Yeah, so what is a prototype design pattern? The prototype design pattern is a creational design pattern that creates new objects by copying an existing object instead of creating a new one from scratch. In simple terms, you can say instead of building a new object, we just clone the already existing one. You use it when creating an object is expensive or complex, or when you want to duplicate objects quickly, and when you want objects with similar properties. That's the appropriate time to use the prototype design pattern. Let's go to the next slide. Yeah, the slide we have a prototype design pattern example, which is our core class. It implements the clonable interface, indicating that we want the core class to be clonable. Below we have our brand attribute, and below that we have our car constructor that takes in the brand string and set our brand attribute. Below we have our show car method that prints out the car brand, and below lastly we have our clone method that's responsible for cloning the car object for us. Yeah, so let's go to the next slide. The next slide we have our main class and our main static method, and as we see there, firstly we have our car1 attribute, which is equal to new car, and we pass in the Toyota brand as a string. And below that we have a car2 and car2 reference, and we say equals to car1 dot clone, cloning the car1 object. So below that we trying to invoke show car, the show car method for the first object, and the show car method for the second object, which is the clone object. The expected result should be car brand is Toyota, car brand is Toyota. Car brand Toyota should be printed out for both methods, since car2 is the exact duplicate of car1. Yeah, so yeah, that's a quick overview on the prototype design pattern. Next we'll be coding we'll be coding the prototype design pattern and I'll also be talking you guys through the code. Yeah, so yeah, let's go. Now let's code the prototype method design pattern that was on our previous slide. Okay, make it a core and implement the clonable interface, and then have a string variable of our brand, and then have a public core constructor, we're taking a brand string, and assign our brand attribute, and then public object clone, return super clone. Let's see, yeah, we are required to have the clone not supported exception handler. Okay, so now let's run over to our main, say car, wait, create a car, it's public, tripping, yeah, prototype, import, function, new car. Okay, let's say BMW, let's say BMW for now. Car, clone, and exception handler for that, yeah, and just cost them. So let's say car, oh, okay, so it's my bad, it's supposed to have public void show car method, and what this method should do is print out car brand, yeah, we should print out the car brand. In this case, I'd expect control, yeah, I'd expect to have car brand BMW printed out. Lovely. We have car brand BMW printed out for the first original object, and car brand BMW for our cloned object. Yeah, ladies and gentlemen, that is a prototype method design pattern. Yeah. So what is the builder design pattern? The builder design pattern is a creational design pattern used to create complex objects step by step. It allows you to construct an object with many optional parts without using a large constructor with many parameters, which is one of the cool things about the builder design pattern. So here we have our builder design pattern example, which is the phone class. So we will be, this is the first layer of our example, so we will be using the builder design pattern to actually build up our phone class, our phone object, my bad. We'll be using the builder design pattern to actually build a phone object. Let's go on to the next slide. Perfect. Now this is our phone builder class. This class have functionalities that utilize the builder design pattern to actually build our phone object up. So after we've changed the set, like setting the brand, setting the storage, and setting the camera up, right at the end we will be required to use the build method right at the bottom. That build method at the bottom is responsible for actually constructing our phone object. We won't have to add a new phone object and then pass in a whole lot of params. We can easily just build our phone object up using the builder design pattern. Let's go to the next slide. Here we have our main class and our main static method, and we have our phone reference that equals to the phone builder class. The phone builder class utilizes the builder design pattern. That's why you see we have the .set brand and .set storage, .set camera. We can have this we can have the sets in a chain format, and then right at the end we have a .build. We have a .build. The .build is the method that's responsible for actually setting our phone object, what the values that we've passed in our phone builder object through the sets. Right below we have the phone.show. We trying to invoke the show phone method, which should print out brand and the brand that we've passed in, and the storage value that we've passed in, and the camera megapixels value that we've passed in. So this is our builder design pattern. So let me go back to show you guys the show phone method, what it have. We're just printing out the attributes in a proper way. That's why, let me go back. The expected results are as they shown here when we try to invoke the show phone method. Next we'll be coding this example. And when we code stuff, things start to make a whole lot of sense. Now let's code our builder method design pattern that was shown at the slide. Hopefully now it could make a whole lot of sense when you code it. Okay, let's say phone class. Perfect. Let's string brand name private and storage private camera public phone public void show phone brand okay. This is just a method so and so so this show phone method is the method responsible for actually it's just a verification method that I want us to invoke at the end so that we can actually see that our phone object have been successfully constructed. And then now let's go to our main guy, our phone builder. Phone builder class that's responsible for us that's using the builder pattern to help us build our phone object up. And we say set brand and phone builder return this, and then set camera phone builder return itself again, set storage, then return itself and builder, and then at the end let's say public phone build, the method that's gonna help us out in building our phone object. Okay, let's say brand name. Okay, let's look at the elements. Okay, storage and camera. Yeah, let's look at that. Perfect. Now we have our phone builder. This is our phone builder class. It's making use of the builder design pattern in helping us construct a phone object. Yeah, so let's go to our main class and try to test this out, see if you can actually build a phone. So equal to new phone builder dot set name. Okay, let me say how to can and set camera send 20 and set storage and say 100. Okay, and then dot build to build our object, and phone dot show phone. Let's see if like our phone is successfully constructed. Let's verify. Ah, lovely. The brand is LG. The camera 20 megapixels. Storage is 100 gigabyte. Yeah. So yeah, the phone object is quite small and it has fewer variables, but the builder pattern becomes quite useful for objects that take in large variables, and for objects that are versatile, where you can actually where there could easily be cases where you wouldn't want to set certain variables. Previously you would just have to add your new phone object and just pass in your parameters at the constructor, but when you're dealing with a object that contains a whole lot of attributes, yeah, it becomes quite messy, and yeah, it's quite hard to keep track of if you've set this value and if you didn't. The builder pattern also allows you to see the appropriate attributes that you've set. Yeah, it's very nice, cool design pattern. Yeah, one of my favorites. Yeah, okay guys, yeah, that's it on the builder method design pattern. Yeah, thanks for staying with me up until the end. Yeah, this is the end of the Creational Design Pattern series. But yeah, please, if you're new, hit that subscribe button and stay tuned, because there's a whole lot of cool content on the way, a whole lot of cool stuff. This is just the beginning. Yeah, okay, then yeah, peace out.